Hello everyone, my name is Eric Bernabe and this is my 10-minute presentation for the UF3 cryptography assignment. The main goal of this project is to replicate the core functions of Java's Keytool utility using Python. So our program must be able to firstly securely generate an asymmetric key pair and store it in an encrypted key store. Then it has to extract a certificate signing request from that key pair, and finally it has to manage all of this from a command line interface. So for doing that, my presentation will be divided into four main parts. First, I will demonstrate the real Java key tool to set a benchmark. Then I will do a high-level code walk through my Python script in Google Colab. After that, I will run several test cases on my Python simulator to prove that it works and it can handle errors. And finally, we have a brief conclusion of the project. So let's begin with part 1, the real key tool. For the first part, let's start by going to the local command prompt. That's because the Keytool program is not automatically in the system path. It's an executable file located inside the bin folder of my Java development kit installation. So first I must navigate to that specific directory using the cd command, and my Java development kit is the 23 version and it's installed in the program file. So let's go to it. Okay, so now that I am in the correct directory, I can run the Keytools commands. As you can see here, this is the directory that we have to go to. So let's just execute this command, and it's gonna ask us to type a password. So let's break down this command. So you can see here, firstly we have the gen key pair. This is the command to create the new keys that are gonna be inside our file. Next we have the key alg RSA, and this is specifying the algorithm to be this one. Then we have the alias here that puts a unique nickname for the key. In this case is real Java key. And then we have the file where the keys will be stored. In the key store, this one, the real key store. Okay. And finally we have the key size that defines the strength of the key, as you can see here. Okay, so to start, let's gonna type a password. Yes. As you can see, if we type password of less than 6 characters, it will say us that it's an error and we have to type another one. So let's type one that it's correct. In this case, it's correct. Okay. So next, it asks us for our distinct guy's name information, and this is what identifies the owner of the key. So I will just enter test for the common name and skip the rest. Finally, it asks us if all the information is correct, so we are gonna just type yes and press enter. Okay, so as you can see here, it's all correct and it created the file with a validity of 90 days in this algorithm. So as you can see, if we go to the path user my project Keytool, we can see the file that has been created. If we open it, all the information inside is encrypted. Now to create the CSR, we use the certrec command. Notice that they must use the same alias. As you can see here, real Java key, and the same key store, the real key store. I have named the output file real Java request CSR. Okay. So when we enter, it just asks us for the key store password, and that's done. Okay, we enter it and the file is created. So we just have to go to the path. Here, my project Keytool. Here we have the file. If I open this new CSR file, you can see that it's a standard-based 64 pin format, and it begins with begin certificate request, and it ends with new certificate request. So this is the exact behavior we need to simulate in Python. Alright, so we are back in Google Colab, and this is my Python script. Instead of reading every line, let's look at the three most important logical blocks that are derivar clase, cifrar datos, and descifrar datos. Okay, so let's start with derivar clase. Here we use this right here, that is a key stretching algorithm that turns a simple user password into a very strong secure encryption key. Then here we have the cifrar datos and the descifrar datos, that they use Fernet, which is a symmetric encryption, to completely lock and unlock the entire JSON key store file. If you enter the wrong password, the descifrar datos will fail and it will return none, stopping the program. And this is our first layer of security. So now if we go to generar clave that we have here, this one basically is the gen_key function. First it asks us for the key store password to decrypt the main file, as you can see here. Then it asks for a new unique alias and a new key password. This is our second layer of security that we do here. And then it generates the 2048-bit RSA key pair, and then it encrypts only the private key using that new key. Here it generates the key, and finally it adds the new data to the dictionary and calls guardar key store to re-encrypt the entire file with the key store password. Now if we go to solicitar certificado, that solicitar certificado, it's gonna be right here. We can see that this is the certrec function. It requires both passwords, the key store password to open the file and the key password to decrypt the specific private key. It asks for the distinguished name information. As you can see here, we need the passwords, and then we need here the information. So it also uses a builder, and it constructs the CSR, and the most importantly syncs with the private key. The signature is the mathematical proof that we own this key, and then finally it saves it in a CSR file. Finally, we have the main function principal, and this function uses argpace to create the command line interface, parsing arguments like jk and calling the correct function. And this one, to use it, we have to import over here. Okay, so basically that's all the code, and now let's move into the test cases part. So first we have to install the cryptography library. As you can see here, it's already installed, so let's move to the cases. We are gonna start with the help command. As you can see here, if we execute the command, we can see that it correctly displays the help messages, the help message listing the commands, the Yankee command, the servec, the export, all the help. So let's move to the next one. The next one will be the Yankee command, and this one will create our JSON keystore file. So it asks us to put a keystore password. We type it, then we have to type our alias, and then we have to type a password for our alias. Okay, so now we can see that the key pair is saved. So if we refresh the file, we can see that our JSON file is created, and you can see that all the information here inside is encrypted. So this proves that our cifrar datos function is working. Now for the next command, the servec, we are just gonna use the key that we have just made. So let's type it. Here it displays us the alias that are available now. So let's type Eric. Let's type the key and the password for Eric. And now we have to type some information that we need to provide to the file. Yes, we just put this. Okay. So now our CSR array is created. If we open it, we can see that the standards begin certificate request format that is a perfect match. Okay, so now let's start with the failure test. So first we are gonna type a wrong keystore password. As you can see here, if we type a wrong keystore password, it will say to us that it's not the correct one, and it will display an error. But what will happen in the case that the keystore password it's okay, but the wrong one is the key password? So let's look at it. As you can see here, we have the alias of Eric, but now it will say us that we have to type our password. If we put a wrong one, it will say that our password is not the correct one, and it will display an error. Also, we are gonna do a final test that it's that what will happen in the case that we want to create a key with a duplicate alias. As you can see here, let's start by creating. We have to type the password. If you type it wrongly, it will display an error. So we have to type it correctly. We have to introduce the new alias. If we introduce the same one, it will say to us that that alias it already exists. So this proves the logic of our code is good and robust. Okay, so basically that's all the code, and now let's move into the test cases part. So first we have to install the cryptography library. As you can see here, it's already installed, so let's move to the cases. We are gonna start with the help command. As you can see here, if we execute the command, we can see that it correctly displays the help messages, the help message listing the commands, the Yankee command, the selrec, the export, all the help. So let's move to the next one. The next one will be the Yankee command, and this one will create our JSON keystore file. So it asks us to put a keystore password. We type it, then we have to type our alias, and then we have to type a password for our alias. Okay, so now we can see that the key pair is saved. So if we refresh the file, we can see that our JSON file is created, and you can see that all the information here inside is encrypted. So this proves that our cifrar datos function is working. Now for the next command, the selrec, we are just gonna use the key that we have just made. So let's type it. Here it displays us the alias that are available now. So let's type Eric. Let's type the key and the password for Eric. And now we have to type some information that we need to provide to the file. Yes, we just put this. Okay. So now our CSR is created. If we open it, we can see that the standards begin certificate request format that is a perfect match.